Hi there guys, and welcome to this video on perimeter of sectors. So in the previous video we talked about sectors being an arc length, which I'll just highlight here again. So we have an arc length here and here, and then we have, in this first case, a diameter, and in the second case we have two radii. Well, a diameter is two radii, so basically we have the same picture, just presented slightly differently. Now, to find the perimeter, in the previous video we found an area, so to find the perimeter we just have to look at this arc length and then add on this little bit here, this straight line. So an arc length is anything just that's not straight, basically, so a fraction of the circumference. So perimeter is equal to arc length plus diameter in this one, but most often it would be the arc length plus 2 radii. Okay, so how would we find the arc length? Well, that would be pi times d for the entire circle. That would be the circumference of a circle. But this is half a circle, so we only want half that length, so we're going to divide it by 2. Or we could have said half pi d, whichever we want to write. And then we're going to be plus d. So this one here on the right, it would be, well, pi d would be the entire circle, but this time we're going to divide it by 4 and then add on 2 r's. Okay, so that's your formula. We haven't got any numbers on here, but we'll start to put numbers on as we go through. So maybe for this one, so let's put 6 centimeters on here, and let's put something like 8 centimeters on here. So let's find the perimeter of these. One on the left is definitely easier. So perimeter is the arc plus 2 radii. Well, we know that is plus 12, so let's just pop that on there. But the arc, right, so it is pi d, that's the entire circle, but we have a sixth of a circle here because there are 6 of these. So I'm just going to put a sixth here. I could have divided by 6, but I chose not to. And actually that's a bit of a silly thing to do because I know what the diameter is, don't I? Which is 12, so half of 12 pi. So I could even go one better here. I could say that's 2 pi plus 12, and that is my exact answer. But if I want to work it out to, say, 3 significant figures, I just quickly type this in, and I get 18.3. Okay, so you'll notice I only picked up my calculator when I was here. Lots of people pick up the calculator before they've even written anything. Do not do that. Okay, let's go again. So arc plus 2r. This one, this is not like a friendly fraction. So this is 55 out of the 360 degrees of the entire circle times pi d plus 2r. So in this one I felt a bit bad because I didn't write the formula very well. So this one I'm going to make up for it. So 55 over 360, pi d, well 16 is diameter, so I've got 16 pi plus 16. Okay, it's just a matter of typing that in now. It's not going to be a nice number there. So 55 divided by 360 times 16 pi plus 16, and I get 23.7, sorry but they're right in there, centimeters, and that's the 3 significant figures, and I should have put that on here as well. That's it. Okay, so to sum up, you have the arc length, which is a fraction of the circumference. I used to use this formula. I prefer it actually, 2 pi r, so 2 r's is the diameter. Just you write it that way because these are both numbers. This is an unknown. Plus 2r. So that's the formula. So let's now apply that to some harder questions. So here's one. Now this is a rubbish question. Let's make it harder, right? So let's calculate the perimeter. That's definitely harder. Yeah, have a go if you want to. Pause the video, see what you can do. If not, just sit tight and we'll go through this together. So we have the arc length to be 4.4, so let's pop that on there. So this is like a reverse problem. Definitely harder. So what do we know about the perimeter? So we know the perimeter is the arc plus, no, My question's rubbish. Their question was way better. So we're going to do theirs. Right, so it'll be the arc plus 2r. Well, okay, that's really easy. Mr. Wilson, you're an idiot. So 2r's, so 2 6s are 12. So we have 16.4 centimeters. No wonder they didn't ask that question. It's rubbish. It's easy. Okay, so let's just work out the angle here. So what we know is that theta divided by 360, so the fraction of the circle, times by pi d, so that would give us the arc length. Well, we know the arc length is 4.4. So this is actually just one term here because it's timesing. We only have terms when it's add and subtract, but I tell you what we can do. We just tidy this formula up a little bit more, but we have to think about isolating this theta on its own. So that's going to be 12 pi, the diameter is 6. So to isolate this theta, to make theta the subject of the formula, the first thing I'm going to do is divide by 12 pi. So I'm going to write theta over 360 is equal to 4.4 over 12 pi. Now to get theta on its own, I'm going to times by 360 to both sides. And again, I'm only picking up my calculator at this point, not earlier. Get in a habit, get in a good habit, basically. Okay, what do I get from this? I get 42.0 degrees. That's the 3 sig fig. So it's tempting, if they say 3 significant figures, you just write 42. Don't, because the 0.0 is there to show that it is correct to 3 sig fig. So make sure you add that bit on. Okay, so maybe I won't change this question. Let's see how it goes. I'll change it at the end if we need to. Okay, so this time we've got this language here of major arcs, which we spoke about in the last video. But the major arc is the larger one. This here would be the minor arc. Okay, so if they're talking about major arcs, we actually need the angle for that. So angles around a point, don't ever write angles in a circle because, okay, in this case there is a circle, but angles around this point are 360, so that's 324 degrees. Okay, and we know this arc length is 31.1 because they've told us that down here. So, what do we know? We know 324 divided by 360 times pi d equals 31.1. This time we have to find the radius, so we can do that if we know the diameter. So again, lots of people just look at this and go, I don't know where to start. Just write down the formula. Just pop the numbers in that you know and go from there. So let's isolate pi d. So we're going to divide both sides by 324 over 360. Type that in as I go, and I make that 311 over 9. Okay, so to find the diameter I'm going to divide by pi. Now if you're really unhappy with what I've written there, you could have just written divide by pi, but let me show you why I've done that, because it's a good mathematical knowledge. So if I'm dividing by pi, which is what you could have written, imagine that is pi over 1, because it is. Dividing fractions, we keep, we change, and we flip. Multiplying fractions, you times the tops, and you times the bottoms. So it's a good habit to get into. So let's work this out. So 311 divided by 9 pi. So the diameter here is 10.999 blah 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 blah. Whatever you do, don't round. We need to half that, so divide by 2. Okay, so the radius is 5.4996. So they haven't asked us to specify a rounding. So I'm going to change this question. Let's find the perimeter. That's what I wanted to do before. I didn't dare change it after how embarrassing it was last time. So the perimeter is equal to the arc length plus 2 radii. So it's 31.1 plus 2 lots of 5.4996. So I'm just going to times by 2 plus 31.1, and the perimeter for this one would be 42.1 centimeters to 3 significant figures. Okay, so you've got some reverse problems there, you've got your basic formula, you just need to go away and practice. You shouldn't find this one too tricky.